How's it going, Warhawks? This is Mr. Tipton. We're starting Chapter 9. This is going to be a unit on trigonometry. You may have seen buttons on your calculator, SIN, COS, TAN, and you probably never knew what those meant. In this chapter, we're going to figure out what SIN, COS, and TAN, or sine, cosine, and tangent, mean. So as we look at Chapter 9, a couple of key terms that we really want to focus on here. First of all, trigonometry is used to find missing sides or angles of right triangles. Very important. We will use some trigonometry or some ratios in triangles that aren't right, but right now we're focused on right triangles. There's going to be some key terms here. Our reference angle, first of all. This is going to be the angle that we base our answers on. They'll say use this angle, or what's the sine of this angle, or what's the ratio of this angle. That's called our reference angle, the one that we want to look at. We also have a side that's called an opposite side, the side across from the reference angle, an adjacent side, the side touching the reference angle, and I should say that's not the hypotenuse, because the hypotenuse always touches the reference angle. And then we also have the hypotenuse, which you should be able to identify in a 90-degree triangle. So here we see a picture. Right now, I'm going to say that angle A is our reference angle. And I like to put a mark through my reference angle just so I know which one I'm looking at. So our answer here, our reference angle is going to be angle A. So that's where we're going to base everything off of, is where angle A is located. So now we have three different sides. We have a side that's opposite of angle A. Now, when I'm looking at angle A, I like to think of the opposite side as the side that doesn't touch angle A. It has nothing to do. So these two sides touch angle A. They create it, really. BC does not create angle A. So BC is going to be the side that's opposite of angle A. So I'm going to say BC, an adjacent side to angle A. Now, you'll notice that we actually have two sides that are adjacent to angle A. It's the sides that create angle A. So one of them is not called adjacent, though. It's called the hypotenuse. So even though AC is adjacent to angle A, I don't call it the adjacent side. It's the hypotenuse. The other side, though, is going to be my adjacent side, which is side AB is my adjacent side. And then lastly, we have the hypotenuse. The hypotenuse should be easy to identify. The right angle always points to it. AC is going to be our hypotenuse here in this picture. Now we're going to look at the same triangle in this next example, but notice how I've changed my reference angle. This time I want my reference angle to be angle C here. So I mark it, and everything changes. Since my reference angle is angle C, now the side that's opposite of C, the one that doesn't make C, those two sides are used to make C, AB is opposite of angle C. It's across from it. So now AB is my opposite side, as opposed to BC being my opposite side in the last example. Notice how when we change the reference angle, how we list the sides change. The side that's adjacent to angle C is the one that's next to it. There's two sides that are adjacent to it. Just one of them we call the hypotenuse. So the one that's adjacent to C, that's not the hypotenuse, is going to be BC. And then the hypotenuse, again, that's the only thing that doesn't change. The hypotenuse of that triangle is still AC. Okay. So as we move forward here, keep that back up there. We want to use our reference angle A. So A is going to be my reference angle. I marked that just to kind of remind me. And I want to write the ratios for the opposite over the hypotenuse. Now this is how we do this. They're going to have some questions that ask you to write these ratios. So angle A is here. Which side is opposite of angle A? Well, that's going to be BC. So when I write the ratio, I can actually list the side length, 6, over the hypotenuse, which in this case is 10. So using reference angle A, opposite over hypotenuse ratio would be 6 over 10, which you could technically reduce to 3 over 5. Your book has you doing that, but really we don't always need to do that in order to find the side lengths, but you can. The next ratio is adjacent hypotenuse. So we're looking at angle A. Which side is adjacent to angle A? Well, 8 and 10 are both adjacent to A, but one of them is the hypotenuse. So the adjacent side is going to be the side that's 8. The hypotenuse, again, is 10. And you could, again, reduce that to 4 over 5. We should always probably reduce ratios to their lowest terms. And then lastly, they want me to list the ratio for opposite of A over the adjacent side. So the side that's opposite of A is 6. The adjacent side is 8. So my ratio is going to be opposite 6 over adjacent 8, which I can reduce to 3 over 4. Let's look at another example. Now this time I've changed my reference angle. Same triangle, except now I'm looking at angle C as my reference angle. So the side that's opposite of C, notice how the one that it doesn't touch is AB. So opposite, my number that's going to go there is 8 over the hypotenuse, which is still 10. So I reduce that to 4 over 5. So 8 over 10 is my opposite ratio, opposite over hypotenuse. Adjacent over hypotenuse, again, I'm looking at C. The two sides that are adjacent to it are 10 and 6, but 10 is the hypotenuse. So the adjacent side to C is going to be 6. And again, the hypotenuse is 10, which I can reduce to 3 over 5. I don't really need to reduce them, but I will because I think your book has you reducing them. And then lastly, opposite over adjacent. So here's C is my reference angle. The opposite side is 8. The adjacent side is 6. So opposite of C is 8. Adjacent is 6, which would reduce to 4 over 3. Okay, so make sure that you're familiar with opposite, adjacent, and hypotenuse and understanding it based on the reference angle. Now, one thing I will list here is the right angle will never be our reference angle. We don't list stuff according to the right angle, so you don't have to worry about that one, but the other two can be our reference angle. All right, we'll see you in class.